Okay, well, we're going to take a look at section 5.2. We'll be spending 2 days on it. Here's day 1. Once again, looking at quadratics, looking at parabolas. And let's take a look here at the top of the notes. It says, given the vertex form of a quadratic function, you can see that this is looking a little bit different from the way we started chapter 5 off. This is vertex form. Remember, if A, and this is the same A that we studied in section 1, if A is positive, the parabola opens up. It would look something more like this. If the parabola is going to open down, we're going to have A being negative, and it would look something more like that. The vertex of a parabola is the highest or lowest point. It's the highest or lowest point. And we actually were building our table around that vertex. We know that the axis of symmetry is a vertical line containing the vertex. It goes right down the middle of the parabola, and we get symmetry in that process. The axis of symmetry for a parabola is the line x equals opposite b over 2a. The vertex is going to be the point h comma k, and our h is going to be represented as opposite b over 2a. So, this is review except for the form of this new way of writing the parabola. You can see up at the top of the page, I've highlighted it, a times x minus h quantity squared plus k. The h and k are actually in this equation. It's actually really nice for us to see that. Here's our h, here's our k. So let's go ahead and take a peek at this first example and see if we're going to be able to work this out. Our vertex, this is kind of a wonderful shortcut form. The vertex we are going to find immediately. Remember what we just wrote up above. It was a times x minus h quantity squared plus k. Well, you can see inside of this equation, for example 1, we have x minus 2. That means that this is our h right here. We have 2. Our k is right over here. My goodness, we have immediately our vertex. What a tremendous start to graphing this. We now know that our vertex is the point 2 comma 1. And you might remember in the previous section, what we were doing is we'd always go one step larger than the x value of the vertex. If we're at 2, if we add 1, we'll go up to 3. We could also go one step smaller, and 1 unit smaller than 2 is 1. 2 minus 1 is 1. Similarly, we could continue to get bigger. We can plug in a 4, which is 1 step bigger than a 3. We could plug in a 0 over here. And once again, just as we were doing on our previous section, we're just going to plot points. We could plug in a 3. Now look what happens when we do this. With a calculator, this can be done so super fast. Remember to put in parentheses. If you were to enter this into the calculator very quickly, and by the way, 3 minus 2 is 1, 1 squared is 1, 1 times negative 2 is negative 2, negative 2 plus 1 is negative 1. So you can see very quickly we'd get a y value of negative 1. You might wonder what happens if we were to plug in a positive 1 for our x. Replace x with a positive 1, and you can see that 1 minus 2 is negative 1, but negative 1 squared is a positive 1. 1 times negative 2 is negative 2. Negative 2 plus 1 is negative 1. Just as we saw in the previous section, we have symmetry. We have those y values being equal, and they always will be equal. Do in fact work that through. Make sure that you're checking that. If you don't want to just blindly assume that that's the case. If you had made a mistake, you will catch it as you're working it out, and it only takes a second. Let's also let x equal 4. Replace your x value of 4 in that original equation. 4 minus 2 is 2. 2 squared is a 4. 4 times negative 2 is negative 8. And negative 8 plus 1 is actually negative 7. So we'd get all of this to be negative 7. You might wonder if this is what we get when we plug in a 0. It certainly should be. Let's make sure that it is. Real quickly, 0 minus 2 is negative 2. Negative 2 squared is a 4. 4 times negative 2 is negative 8. Negative 8 plus 1 is in fact negative 7. So we would get this confirmation. So what will this graph look like? Well, let's plot the vertex first. 2 to the right, up 1. We can see that we're going to be at 3 comma negative 1. 1, 2, 3 steps to the right, down 1. 1 comma negative 1, 1 step right, 1 step down. 4 to the right, 1, 2, 3, 4, and then we're going to go down 7. That's going to be right over here. And just as well, we'd have 0 comma negative 7. Once again, you get this very nice looking parabola, just like so. And your axis of symmetry is a vertical line. The axis of symmetry is the line x equals 2. Vertical lines have Vux as our mnemonic. Vertical lines have undefined slope, x equals a number, so we'll have x equals 2. So this is how we very quickly can graph some of these problems. Let's go to the back page real quickly and take a look at number 2. Number 2, what a great example this is. Let's remember that we've got a times x minus h, quantity squared plus k. As we're looking right here, you might wonder what your vertex is. This might look a little bit different. Sometimes kids look and they'll look on their notes, they'll say it's x minus h quantity squared. They'll say, look, this is x plus 1. What's going on? Well, you could think of this as if it was really x minus negative 1. Yeah, it's x plus 1, but we could rewrite it in the form x minus h, and then you could see that your h is actually going to be negative 1. Your k clearly is a 4. So we could definitely write it in that form. Moving on, we could very quickly make ourselves a table. And we will orient our table around the point negative 1 comma 4. By the way, just one more thing to help kids out. What they'll notice is inside parentheses, you can just choose the opposite of what's inside. If you see a plus 1, obviously you're going to see a negative 1. Going back just real quickly, when we saw this x minus 2, we actually had a positive 2. Many kids realize that very quickly, and this is just a little help to speed up finding the vertex. So we've got negative 1 comma 4. Let's get one step bigger at 0. One step smaller would be at negative 2. Another step bigger would be at 1. Then right here we'll be at negative 3. Let's quickly go through this and plug in a 0. If you were to plug in a 0 real quickly, you could actually get 0 plus 1 up in here is 1. 1 squared is 1. 1 times 2 is 2. 2 plus 4 is actually going to be a 6. If you were to plug in negative 2, negative 2 plus 1 is negative 1. Negative 1 squared is a 1. 1 times 2 is 2. 2 plus 4, again, is a 6. Here you get your symmetry. But again, all I'm doing, plain and simple, and you can use your calculator to do this to speed it up, you just plug these x values in, work it all out. Plugging in a 1, well, if you plugged in a 1, you'd get 1 plus 1. You'd have to square that. 1 plus 1 is a 2, and 2 squared is a 4. 4 times 2 is 8. 8 plus 4 would actually be a 12. It looks like we're going to be getting a little too big to fit this onto our graph here. Of course, we could add additional tick marks here if we needed to. -3, if you were to plug that in, you would actually get the exact same value. You're always going to get these symmetries here, but again, double check that. It only will take you a moment to plug -3 in. Let's just graph -1, 4, 1 to the left, up 4. 0, 6 would be over here. We'd be at -2, 6 would be over here. 1, 12. Well, if this is 7, 8, maybe even right here, this would be sufficient just to have a quick graph. It would look something just like so. Axis of symmetry goes right down the middle of your vertex. The axis of symmetry would be the equation x equals -1. All right, real quickly, just wanted to briefly change this next problem, and I meant to change it in the notes, but we're just going to do this right now. Here's a slightly different. Instead of a +3, we'll have a -3, and of course we can very quickly find our vertex. The vertex, and again, kids will really notice once again that we've got our x minus h. You see a -2 in there, you'd know that your vertex would have to be a 2 for that x coordinate. As I said before, you can also just quickly choose the opposite of the number inside of that parenthesis. That's a quick way to do it. But again, kids might look back on the vertex form. I'm going to highlight this over here again. They'll say, well, wait a minute, I have a +k in this vertex form, and they come over here to problem number 3, and they'll say, well, wait a minute, I see a -3. What's up with that? Well, remember the -3 you could write as plus a -3. So really our y coordinate here is going to be -3. So that's our vertex. Very, very quickly, we'll have 2, -3 over here. Build your table by choosing values bigger and smaller than the x coordinate. If x is 2, we could get one bigger, one smaller, get another step bigger, another step smaller. For the sake of time, I'm running out of time with the video. I only have another couple minutes left. But if we were to real quickly work this out, you could see by plugging in a 3, you should get a y value of -4. Same thing with 1. Again, you're going to get your symmetry. If you were to plug in a 4, well, 4 minus 2 is 2. 2 squared is 4. -4 minus 3 is -7. Plugging in a 0, you would actually get that exact same value. Here's our axis of symmetry. It would be the line x equals 2. And then very quickly, let's graph it. 2 steps to the right, down 3 would be your vertex. We could go at 1, -4 would be right over here. 3, -4 would be over here. 0, -7 would be this location. 4, -7 would be right over here. There you have it. A nice looking parabola. When your a is negative, you know it's opening down. Hope this is helping. Again, the vertex form, it can speed up these problems quite a bit. That's all for today.